So one thing that we did that we're really pleased about was create the first international staging system for Merkel cell carcinoma. This was another example of collaboration with 10 centers across the country, where it replaced 5 different conflicting systems. You said, I have stage 3 Merkel cell carcinoma. No one would know what you meant. They were all conflicting. And it also showed that node biopsy is important. I'll tell you what that means in a moment. So Bianca led this study. She's now a dermatology resident at Emory. And we showed the pathologic node evaluation, which means looking under the microscope. Pathologic node evaluation improves prognostic accuracy, figuring out if somebody's going to die or not, basically, of Merkel cell carcinoma, looking at 5,800 cases and creating a first consensus staging system. And the crux of that was looking at these national data on Merkel cell carcinoma, almost 6,000 patients, 2/3 of them, 68%, didn't have anybody look microscopically at their lymph nodes. And that turns out to be very important because this cancer is 30 times more likely than melanoma to have spread to lymph nodes at the time of diagnosis. Even if you feel the lymph node bed and the doctor and the patient says, I don't feel any lump there, it's present in 1 in 3 cases. So this is a very helpful thing to point out, and both for figuring out chances of death and for figuring out how the best way to treat it is. And so this is how survival looks. And I only want to point out, so this is 5 years. This is survival for the best stage 1A, the small guy with nothing in the lymph node, versus distant disease at the time of diagnosis, stage 4. I just want to point out the very best group, 1A, still has a 1 in 5 chance of dying, basically, of its cancer by 5 years. So it's quite aggressive cancer, and it obviously sends a message that node staging matters, because there's a big difference between whether your nodes were negative just by the doctor feeling or by looking under a microscope. So here then comes the ultimate serendipity in my professional career. A couple years after I moved to Seattle, Yuan Chang and Patrick Moore, the dynamic duo in Pittsburgh that found the Kaposi sarcoma herpes virus. So if you've heard of Kaposi sarcoma and HIV disease, they're the ones that found that virus. They've hit a giant grand slam home run again and found that there's a new human virus in 2008 that causes Merkel cell carcinoma in most cases. And interestingly, it was present in 80% of the cancers, and that was in their original report. This has been validated in dozens of studies, over 1,000 patients, and it's right there at 80%. And the fascinating thing is this virus is everywhere. It's on the doorknobs. It's on our skin. We take a cotton swab on half of the people's foreheads in this room. We'll get this virus off of normal appearing skin. So how does that happen? This is all over all of us. Kids are seropositive. That means they make antibodies to this virus by the time they're 5 years old in the daycare center. And yet only 1 in 3,000 people will get this cancer over their lifetime. How does that happen? Well, I'm not going to take you through the gory details, but I'm going to tell you it's a story of a cat and mouse game between the virus and the immune system. This virus is all over our skin, but usually it just lives on the outside. It doesn't make trouble. It doesn't actually integrate into our genome. But when you combine some bad luck with usually some sunlight, then it can rarely integrate into the genome, and then it can get cut in half in a particular way that is necessary for the cancer to grow, but would make the virus dead. So that's a very strange, weirdo mutation that has to happen. So those are super rare events. The integration, that is the direct entry into a human chromosome, and then cutting in half in a particular way that leaves a part of the virus intact to make the cell divide, and the rest of it not intact, that would have killed the cell. And then, so those rare events have to happen in terms of the virus getting into the cells of the skin. But then you got to have a wimped out immune system, and that could be from a drug that you take for a heart transplant or something, or it could just be from age as we get older. 94% of our Merkel cell patients don't have any obvious problem with their immune system, but the vast majority are over 50 or 60, and then over that time we could get local or systemic immune suppression, but basically there is some loss of immune function there, and then there's escape, we believe. So I'm going to tell you now about a really exciting thing, the first ever test in the blood for antibodies to a virus that lets us see whether the cancer is coming back or not. This was one of those wonderful collaborators, Denise Galloway at the Hutch, who came to us and said, "We really have to study this cancer. Let's look at the antibody response." And indeed, we found that antibodies to this virus, the particular part of it, the T antigen, reflect tumor burden, whether the cancer is there or not in Merkel cell carcinoma patients. So I first have to tell you there are two conceptually important parts of this virus. One is the coat protein on the outside that allows it to have a little home and float around and move around on the skin. Turns out that most of us in the room have antibodies to those capsid proteins that make up the coat. However, the oncoproteins inside, turns out none of us have. Less than 1% of 500 people who are normal controls, don't have this cancer, have any of those antibodies to the inside protein, but about half of all newly diagnosed patients do. And fascinatingly, while the antibodies here to 10 different patients in different colors over time, the antibodies stay totally steady to the capsid. They fall precipitously. After you cut the cancer out, here days from diagnosis, patient was diagnosed at day 0, they have different blood draws, and then the cancer gets cut out here, and then this is on a logarithmic scale, so this is going down by tenfold, every one of these little ticks. The antibodies are going down fast, and so that's very reassuring. And turns out that every time the cancer comes back, the antibodies go up. So so this is called no evidence of disease. You had a certain amount of these antibodies. A few months later, this patient had metastatic disease, and the antibodies went up by about tenfold, and then they went back down after they were treated again, and the cancer was gone. So this is really exciting. And again, a wonderful collaboration with UW Lab Medicine, and Kelly Paulson led this study, so that we can conclude that these particular antibodies are only present, highly specific for Merkel cell carcinoma patients. Obviously, they're not helping in fighting cancer, and that makes sense. They can't really penetrate inside the cancer cell where that protein is hiding, but they're super useful in detecting recurrence. And we've tracked dozens and dozens of patients now, and at this point, among the patients who made this kind of antibody, about half of all the Merkel patients were in that category. It's really specific, meaning that the antibodies only increase if the disease recurs, and it's really sensitive. Every single patient who has had an increase in their titer has had a recurrence. So we're sure we're going to find some patients that break this rule, but so far we haven't among dozens, and it's being developed now as a formal clinical test that we'll make available, of course, to anybody really around the world, and right now it's available on a research basis and working hard to develop that. So the bottom line then between this virus and this cancer is that it often plays a role, but it's not necessary or sufficient. It's not necessary because 1 in 5 Merkel patients don't have any of this virus in their cancer, and it's not sufficient because, thankfully, we all have this on our skin, and most of us, or the vast majority of us, are not going to get this cancer. So the other trick is that the virus status really doesn't tell you whether the patient's going to do well. So Kelly asked, what really matters in surviving Merkel cell carcinoma? Which genes are associated with a good outcome? And we looked at all of the genes and how much of the given gene there was among 35 patients, whether they survived or not of Merkel cell carcinoma. I'm not going to take you through the details here, but there are 50,000 gene probes across here, and there are 35 patients up and down. The patients on the bottom did great. The patients on the top did poorly, and we're looking for purple at the bottom. So purple at the bottom means genes there are lots of those genes in patients who survived. And we thought we'd find some kind of a tumor suppressor or an oncoprotein, something that drove the cell. No, it's all about the immune system. The patients who responded had enormous responses there was an extremely strong association with the kind of immune response they had and whether they survived or not. And basically, genes that were upregulated in cases that did really well were associated with killer T cells, so-called CD8 T cells. And I won't take you through the details, but these are all genes that they're associated with pulling good T cells out of the bloodstream and getting them to attack a cancer. And we asked then, well, okay, if that's what the genes were telling us, what about if we look at the actual microscope slides of the tumors? So we had a completely separate 146 set of patients, big collaboration again, where it was very easy. It was very hard to get these from 115 different path labs across the country, but very easy to stain them for CD8 and look at whether there were killer T cells there or not. And there were three patterns that we saw. I'm not showing you a picture of a cancer that had no T cells, but there were a good fraction of them that had essentially none. Then, interestingly, there were some that had what we called a stalled pattern. The killer T cells made it into the cancer area, but they couldn't penetrate inside the tumor. This is normal tissue like blood vessels and collagen around the cancer, but there are very few of these brown killer T cells inside. And then some of them had a whole bunch inside the tumor. And that turned out to matter immensely for survival. Here, among patients who had good amounts of T cells infiltrating into their tumor, not a single one of 26 died of their Merkel cell carcinoma. And about 1 in 3 died if they didn't have any T cells or if their T cells were stuck outside of the cancer. And this was stunning when you looked at stage, because these people had local disease. These people had no disease in their lymph nodes already. And these people presented with the disease all over their body. And still, there was 100% survival in all of those categories. So it's really important what's happening with immunity. And here's a completely separate group from Kaiser Permanente that we collaborated with in one of our grants, showing in an entirely separate population, 0 CD8s, grade 1, grade 2, or lots of CD8s, all highly predictive of survival. So why?